For tonight's homework, you're going to be learning more about ratios. This is a concept you learned about last year, but you might have forgotten a little bit. Basically, a ratio is a comparison. We've been talking a lot about doing similar figure problems with scale factors, but now we're going to learn how to solve similar figure problems with ratios. So you can use ratios, R-A-T-I-O-S, to describe and compare shapes. A ratio is a comparison of two quantities, such as two lengths. So whenever you see the word ratio, think about the word comparison. So the rectangle around the original figure, which we're kind of looking at right here, is about 10 centimeters tall and 8 centimeters wide. So this is 10 centimeters high or tall and about 8 centimeters wide. So you could say, or you can say, that the ratio of height to width is 10 to 8. So if I was comparing height to width, I could say it's 10 to 8. You can also write a ratio as a fraction, and that's exactly what I did here. I wrote height over width, 10 over 8. So here I have my original again. So remember it was 10 centimeters high and 8 centimeters wide. And so what I'm going to do is compare this to some enlargements and reductions. So you have some here, left, middle, and right. And I've actually made a table here that shows the ratios of height to width for the images. So a moment ago, again, we were saying height to width, for example, for the original shape, was 10 to 8. So again, here in the table, you can see the 10 and the 8, and then the actual ratio, 10 to 8. So again, we can write a ratio as a fraction, but we can also write it with the word 2, so 10 to 8. You might also see this little colon symbol, 10 to 8, that means the same thing. And now in the table, you also see image information for the left, middle, and right images. So you see that they're comparing, again, the height to width. So the left has a height of 8 and a width of 3. The middle has a height of 3 and a width of 6. And the right has a height of 5 and a width of 4. And so one thing you might notice here is that the comparisons 10 to 8 and 5 to 4 are equivalent ratios. So for example, you might notice that the size is different between these two shapes, or between these two images. However, the ultimate shape of the images is similar, is the same. And so, for example, these two look like they could be similar figures, like they're related with the scale factor, versus the left and middle images look like maybe they were just stretched in one direction. So now equivalent ratios, so again here we're talking about 10 to 8 and 5 to 4 as well, are like equivalent fractions. So we're going to review a little bit about equivalent fractions. So we just identified 10 to 8 and 5 to 4 as equivalent fractions, or also we call them equivalent ratios. And basically we know they're equivalent because you're going to multiply the numerator, the top number in one of them, and the denominator by the same number. And you might think about this also as a scale factor. So for example, I could say that 5 times 2 would make 10, and 4 times 2 would make 8. However, I could also go the other way. So 10 over 8, 5 over 4. I could also say 10 times a half is 5, and 8 times a half is 4. So again, I could go either direction depending on which one I'm starting with. But this is kind of like, again, thinking about scale factors, just setting it up with equivalent ratios or equivalent fractions. So again, you have these guys right here as well. Notice you can flip the fractions themselves as long as you keep the relationship between the corresponding sides the same. So again, in this case, we were comparing height to width. So we needed to have the heights on the top and the widths on the bottom. However, you could also write this as a ratio between width and height. Right? I could compare boys to girls or girls to boys. I just need to make sure that I keep things consistent when I set up my equivalent ratios. I want to make sure that I set up the same way on both sides. So again, you can express equivalent ratios with equations. That's what this equal sign in the middle of the equivalent fractions or equivalent ratios mean. But we also have a special word for that. That's called a proportion. So a proportion is an equation stating that two ratios are equal. So again, when I put that equal sign in between 10 over 8 and 5 over 4, that goes from this being simply one ratio and another ratio to them becoming equivalent ratios, or ultimately a proportion. So let's look at a problem in which setting up a proportion or two equivalent ratios could help you think through what the answer should be. So let's say you want to draw a new figure that's similar to the original, which is right here. The original again was 10 centimeters high and 8 centimeters wide. But now you want the image to be 15 centimeters high. And now you want to know how wide should the image be. So you can kind of imagine that width as our x. So we're going to set up a proportion or two ratios comparing the sides. Again, I need to really pay attention to my order. So I either need to do height over width or width over height, but I have to choose which way I want to do that so that I match up the corresponding sides. So I'm just going to do height over width. So in this case, my height was 10. My width is 8. And my second figure, my image, my height is 15. So I'm going to match up the 15 with the 10 here because these are both heights. And my width over here is my unknown. That's my x. So I'm going to put an x there. So what I need to think about is, what is the scale factor that I need to create equivalent ratios? So I'm going to think about, what would I multiply 10 by to make 15? Well, if I think through that carefully, if I'm stuck, I could always do 15 divided by 10 to find that number, which should be 1.5 or 1.5. So 10 times 1.5 would give me 15. So now I can do the same thing on the bottom. I'm finding that equivalent ratio that goes with this. So I'm finding that same value that will make these two ratios equivalent. I'm going to multiply 8 times 1.5. So I want 1.5 times 8. So that's 8 plus half of 8. So that would give me 12. And so in this case, x is going to equal 8 times 1.5, which is 12 centimeters. So again, that tells me that the height is going to be the width is going to be 12 centimeters. And that's going to maintain that proportional relationship, right? That same ratio, so that these two images, the original and the main image, are going to have the same shape but a different size. And in fact, you can look at this and figure out exactly how many times bigger it's getting, right? By looking at that scale factor. The new image is 1.5 times bigger. So that's it for today in terms of thinking about concepts for tomorrow related to ratios. Again, tomorrow you're going to want to come in ready to set up proportions. Again, a proportion is two ratios that are equal to each other so that you can solve for corresponding sides or missing sides in a figure.